we're going to talk about vectors, section 8.6, vectors. Vectors are something that are used not only in geometry, but science. Sometimes you see them. Pain. So vectors today, section 8.6. A vector is a quantity that has both length and direction. So a vector is a quantity that has both length and direction. The vector below may be named hj or v, vector v there. Hg kind of looks like a line segment or a line there if you look at it. H is what's called the initial point, and J is what's called the terminal point. Now when you think of that, when you think of initial, what do you think of? You think of start or beginning. So H is like the starting point. And you think of terminal, you think of ending. So J is the terminal or ending point. So we're going from H to J. Now again, it kind of looks like a what geometric shape? A ray. Nice job. Yeah, it kind of looks like a ray, but this is a vector. The component form of a vector lists the horizontal and vertical change from the initial point to the terminal point. So it's horizontal and vertical change. So for example, from A to B, I go left 3 and up 4. What's another thing that is very similar to? That's very similar to slope. Okay, it's very similar to slope. The only difference here is we have x and then y, whereas slope is y over x, right? So change the y over the change of the x. So the component form of AB is negative 3, 4. Negative 3 because we went left 3, positive 4 because we went up 4. So the component form was negative 3, 4. You can also find the component form from a vector if you know the coordinates of the vector. Suppose JK has coordinates 6, 0, and K1. Subtract the coordinates of the initial point from the coordinates of the terminal point. So we would do 1 minus 6 and 3 minus 0, and now you get the component form of negative 5, 3. Okay, and again, look, those are not parentheses, they're not brackets, they're kind of like arrow brackets, we'll call them. Just so you know, so those are not parentheses that are around those for a component form. So vectors here. I want to write each vector in component form. So number 1, I am going from F to G. If I'm going to go from F to G, I'm going to go over how many here?
4. Wait, oh, 9.
Isn't it 5?
5, yeah.
I go over 5, and I'm going to go up 2. So the component form is 5, 2. That's it. Number 6, QR. I'm going to go over how many for QR? 1. And I'm going to go down how many? 6. And because I go down, it's going to be a negative 6. And that is the component form. Take a couple seconds to try numbers 3 and 4. Remember, find the component form. You take the terminal point minus the initial point. Take a couple seconds and try those. All right, so let's look at number 3 here. LM with initial point L, 6, 2, and terminal point M, negative 1, 5. What is my component form for that? Mr. Frost. Negative 7, 3 is correct. Nice job. And number 4, the vector with initial point C and terminal point D. What is the component form for that one, Mr. McAvoy? 2 and negative 8. And that is component form. Okay, nice job. Next thing we're going to talk about is we're going to talk about the magnitude. Magnitude. The magnitude of a vector is its length. Now, what's another way to say length? You can also say distance. So magnitude is another way to say length or distance. All right. So the magnitude of AB is written. Now, what do those bars look like to you? Absolute value. Why would you suppose that include absolute value here? Because absolute value is always measured as distance, really. Absolute value just means distance. So the magnitude of a vector is absolute value of that vector. It's distance. Okay. The direction of a vector is the angle that it makes with a horizontal line, such as the x-axis. So what happens here is you draw the vector 5, 2. Well, I go over 5 up 2. Does everybody see that there? Over 5 up 2. Okay, because that's my vector. It's positive 5, positive 2. Now, when I do that, what type of shape do I have here? I have a right triangle. Well, right triangle says I can use distance formula to solve this, or I could use Pythagorean theorem. Now, what do you notice about this? Really, it's just 5 squared and 2 squared, right? And I get the square root of 29, or 5.5.
The joke got less funny because Nick's head takes up a third of the board.
So the next part here. So that's just distance formula. To find the magnitude, you're literally just doing the distance formula, Pythagorean theorem. That's nothing too bad. It's the next part that we need to make sure we pay attention of. To find the direction, draw a right triangle ABC, then find the measure of angle A. So I'm finding the angle measure from the vector to that horizontal line. Well, to do that, I know the base is 5, and I know the other side is 2. Well, to find angles, I use the inverse function. So I take tangent inverse of 2 over 5. Now, why did I do tangent? Because I had the opposite in the adjacent sign. Remember SOHCAHTOA? The TOA is my tangent equals opposite over adjacent. So tangent inverse of opposite over adjacent gets me that 22-degree mark. And that's what we're doing today. So let's try number 5. If I can find the magnitude of each vector to the nearest tenth. Find the magnitude of each vector to the nearest tenth. So, again, think of Pythagorean theorem here, right? What am I going to have first? I'm going to have 3 squared plus negative 1 squared. What's 3 squared give me?
9.
Negative 1 squared give me? 9 plus 1 gets me? So I have the square root of 10. And the square root of 10 to the nearest tenth is approximately what, Mr. Wall? Oh, I thought you had it, man.
3.16.
So to the nearest tenth would be 3.2. So that is 3.2. Nice job. Number 6. Negative 4 6. How would I write that to find the magnitude? Magnitude meaning the distance. Well, I would go negative 4 squared plus 6 squared. Doing that gets me negative 4 squared plus 6 squared gets me what?
16 plus
36.
16 plus 30.
Square root of 52. Because I get the square root of 52. And the square root of 52 comes out to be approximately to the nearest tenth 7.2. Nice job. Number 7. It says draw each vector on a coordinate plane. Find the direction of each vector to the nearest degree. So to draw, I'm going 4, 4. So I'm going to go over 4, up 4. There's my vector. I have over 4 and I have up 4. I want to find the direction. The direction means the degrees here. I want to find the degrees. Well, to find the degrees, what trig function am I going to have to use? I'm going to have to use tangent. So I take tangent inverse. Because inverse means I have to find the degrees. What's the opposite side?
4.
The adjacent side. So I do tangent inverse of 4 over 4. And my direction, or degrees, is going to be what, Max?
45.
45 degrees. Nice job. Now, trick question here, just because we are still reviewing here. What is my magnitude? Who can tell me my magnitude without doing any of the work in radical form? Magnitude in radical form. You should be able to recognize it right away. It's a special type of triangle. It's a special type of triangle, which tells me the magnitude is going to be what, Mr. Nault?
Square root of 52.
Ooh, sir. I want something simplified. Because it's actually what, Mr. Boger?
4 squared.
It is 4 squared root of 2. What type of special triangle is this? This is a 45, 45, 90 triangle. So the legs are 4, which means the hypotenuse is then 4 square root of 2. That's that special 45, 45, 90 triangle. Remember that. Now, you were correct to do the square root of 32, but that does simplify. Number 8. I want to find the direction. 6, 3. So I'm going to go over 6 and up 3. And I have my magnitude here. Or I have my vector, sorry. I have 6 and I have 3. And I want to find the direction there. I want to find that angle. What trig function am I going to use, Mr. Weiss? So tangent inverse of what, sir? No, sir. Other way around. 3 over 6 is opposite over adjacent. So tangent inverse of 3 over 6. Remember to round this to the nearest degree. Tangent inverse of 3 over 6 to the nearest degree is going to be approximately what, Mr. Bennis?
27.
About 27 degrees. Now, knowing triangle inequalities, would that make sense? Yes, 27 is opposite of the shortest side. I would assume that would be the shortest angle. That would make sense. Good work. Take a couple seconds to try numbers 9 and 10. It says draw each vector on a coordinate plane. Then use the distance formula to find each vector's magnitude to the nearest tenth. Take a couple seconds and try those two. All right, let's look at number 9 here. I have a component form of 3, 4. So over 3, up 4. There's my vector. What would my magnitude? Now again, magnitude means distance or length. What would the magnitude of that vector be, Mr. Boger?
5.
It is 5. Nice job, sir. Did anybody work it out and find the degrees? Because I know some of us did. What was the degrees, Mr. Goldat?
53.
Yeah, that does come out to be about 53 degrees. That was to be the direction. Number 10. I have a component form of 2, 7. So over 2, up 7. There's my vector. What is my distance or magnitude to the nearest tenth, Mr. Bennis?
Nearest 10.
Yeah.
I got 7.3.
It's about 7.3. Good work, sir. And then, did anybody work it out? Because I know some people did. What was the direction? What was the angle of that then? I think Mr. Wall had that one. Was it?
I got 17.
It was 74 degrees. Would that make sense, sir?
Yeah.
Yeah, because that's opposite the 7 side, which is larger than 2, right? So it should be a larger angle. Nice job. Take a couple seconds to try numbers 11 and 12. Now you want to find the direction. So now make sure you do that tangent inverse. Take a couple seconds to try these. Number 11. I have the component form of 5 and 5. So there we go. I have 5. I have 5. What is my direction to the nearest degree? Direction to the nearest degree. It is 45 degrees. Because I would do tangent inverse.
Is it always going to be like that if it's like a whole, like how we're trying to do it?
Yeah, because they're the same sides. Now, who can remember here? Trick question again. What's my hypotenuse going to be here technically? Or what's my vector in radical form? Mr. Jacobson, remember this? It is 5 square 2. That's that special 45, 45, 90 triangle. Nice job. Number 12, I have 4, 1. I have 4, I have 1. There's my vector. What is it to the nearest degree, Mr. Bennis? 14 degrees. And again, that would be tangent inverse of 1 over 4. Nice job. Did anybody find the distance or the magnitude on this one? Mr. Wall?
4.1.
It was about 4.1. Good work. Here's your assignment.